All right, today we're looking at rational and irrational numbers. Rational numbers are numbers that can be written as a fraction, and irrational numbers cannot be written as a fraction. And when I say numbers, I mean integers, such as like 2 over 3. That would be irrational. 5 is rational because 5 is the same thing as 5 over 1. We can divide any number by 1 without changing it. 1/4. 0.787878. There's little 3 dots right there. It's going on forever, but because the numbers are repeating itself over and over again, it can be turned into a fraction, is therefore rational. 5.21 with a little line over the top of it, that means the 2 1 is repeating over and over and over again. That makes it rational. 0, -17, and the square root of 16 is also rational because we can put that in the calculator and it would give us 4. Some famous irrational numbers are pi and the square root of 2. That means those numbers go on forever without repeating itself in a pattern over and over and over again. So even though this long number here is in a pattern, it's not repeating itself. It goes 1 and then goes 1 2 1 2 3 1 2 3 4 1 2 3 4 5, and we know it would be 1 2 3 4 5 6, but it's not repeating itself, so it's not rational. Whole numbers are 0 1 2 3 4 5 6, goes on forever like that. Your natural numbers, if I asked you, hey, count to 10, you would start with 1 2 3 4 5 6 7 8 9 10. You start with 1 and you're going up by 1. That's why they're natural numbers. It's intuitive to you. Your integers are your negative integers and your positive integers, and plus 0. So like -10, -9, -8, all the way up to negative infinity and positive infinity. As long as there's no decimal at the end, you're fine. That would be an integer. Your real numbers are basically everything you've seen so far here on the screen. It's easier to show you an example of what's not a real number, which are called imaginary numbers. And the basic example for 8th grade is the square root of -9. We can't take the square root of -9 in our real number system. And you'll learn more about that in Algebra 1, what you would do with that situation. And finally, we're going to convert these following infinite decimals to fractions. You look at how many numbers are under this line or how many numbers are in the pattern repeating itself. And that's how many 9s you put on the bottom. So this 5 would go on the numerator, and there's only one of them there, so we put 1 on the bottom, and that'd just be 5 over 9. 0.71, 71 goes on top, and there are 2 numbers there, so that's how many 9s are going to go on the bottom. 0.237 repeating, 237 goes on top, and then we're going to have 3 9s on the bottom, because there's 3 numbers in the pattern. And the last number, 0.1239, has 4 numbers in the pattern, so that's how many 9s we put on the bottom. And 1 2 3 9 goes on top. And do be careful, because sometimes you may need to simplify it.